In this video, we're going to begin to solve systems of linear equations by the method called substitution. Now, this is not a graphical method where we graph the two equations and look for the intersection. Instead, we're going to do this by solving equations. And this is the way it works. We're going to solve one of the equations for x or y. In this case, we already have an equation, the first equation, that's already solved for y. Then we're going to take that definition of y and we're going to plug it in for y, or substitute it in place of y in the second equation. So what that means is this. In the second equation, we have 6x minus 5y equals negative 19. Now, in place of y, we're going to substitute this other definition of y, which is negative 2x minus 9. The only thing we've changed there is we've taken out the y. We haven't changed the sign. We haven't changed the number in front of the y, multiplied by the y. We just put parentheses where the y was and plugged our other definition, or substituted our other definition for y. Now I'm going to distribute the same way that we have distributed many times since the beginning of the year, and we get 6x. Negative 5 times negative 2x is positive 10x. Negative 5 times negative 9 is positive 45, and that equals negative 19. Combining like terms on the left side, I get 16x plus 45 is equal to negative 19. Subtract 45 on both sides, and I end up with 16x is equal to negative 64, dividing both sides by 16, and I end up with x is equal to negative 4. So what this means is that x equals negative 4 is the x coordinate where these two graphs would intersect. And we didn't have to graph them to find that out. We used an algebraic method called substitution. Well, now we have the x coordinate. What we still need is the y coordinate that goes with that x. So we could plug this x into either one of those two equations there. We're going to use the first one because that one is simpler. All we need to do, it already tells us what y will be if we know x. So we're going to substitute x is equal to negative 4. The only thing I've changed is taken out the x, substituted in negative 4 in its place, and use parentheses because we have these negative signs there. Now, negative 2 times negative 4 is positive 8, minus 9 gives me y is equal to negative 1 for an ordered pair solution of x is negative 4, y is negative 1. And the only thing that I need to do now is to just check to make sure that I have this correct. Since I use y equals negative 2x minus 9 to solve for y, I'm going to plug both x and y into the second equation. 6x minus 5y equals negative 19. Now, I know that x is negative 4, y is negative 1, and when I plug those in, I should come up with negative 19. So let's see what happens. 6 times negative 4, negative 24. Negative 5 times negative 1 is positive 5, and negative 24 plus 5 is negative 19 equals negative 19, and so that is my check, and I know that I have the correct answer there. So this is the procedure that we're going to use then to solve the system of linear equations algebraically by the method of substitution. Okay, in our second example, we are going to do something very similar to what we did in the first. However, we don't have an equation that's already solved for y equals or for x equals. So we're going to have to take either one of these two and solve them for x or solve them for y. So it might be easiest to use the first equation, which is negative x plus y equals 3. Then what I want to do is add x on both sides, and when I do, I get y is equal to 3 plus x, or I could also write y is equal to x plus 3. Now, I know what y is, and so I'm going to go back to my second equation, 3x plus y equals negative 1. And in place of y, I am going to put parentheses, x plus 3, and that's equal to negative 1. All right? So since there's a plus sign on the outside of the parentheses, I can just remove the parentheses, or I can place a 1 in front of the parentheses and distribute multiply x plus 3 by positive 1. When I do, I get 3x. Positive 1 times x is plus x. Positive 1 times positive 3 is plus 3, and that's equal to negative 1. Combining like terms on the left side, I get 4x plus 3 is equal to negative 1. Subtracting 3 from both sides, I get 4x is equal to negative 4. Dividing both sides by 4, I have x is equal to negative 1. Now, second step, I'm going to take either equation, it doesn't matter which one, and plug in x is equal to negative 1. I'll use the first one. There are some complications with that. Negative x plus y equals 3. Remember, when I take out the x, I'm going to leave everything else there and just put parentheses where my new x value will go, and recall that the new x value is negative 1. So you can think of this as the opposite of negative 1, the negative of negative 1, or we can say that it's negative 1 times negative 1, which will give me 1 plus y is equal to 3. Now I subtract 1 from both sides, and I end up with y is equal to positive 2, which would give me the ordered pair solution. X is negative 1, y is 2. Now I still need to check my solution. To check my solution, I'm going to take that ordered pair. I've already used the first equation, negative x plus y, so instead I'm going to use the second equation, which is 3x plus y equals negative 1. Substituting x is negative 1 for x, 2 for y. So let's see what we get there. X should be negative 1, y should be 2, and let's see what it is that we get. Negative 3 plus 2 equals negative 1. We end up with negative 1 is equal to negative 1, and the solution checks out. So my answer to this is the ordered pair negative 1 comma 2. What that means is that if I graphed these two equations, I would see them intersect at the point x is negative 1, y is 2. So we're going to stop this video at this point and go on to some monitoring progress problems in the next video.